Module 14, the respiratory system, factors that aid ventilation. Though I just went over the mechanics of ventilation in the last section, there are other factors that help in this process. A good example of this is elastic fibers in the lungs. This means that the lungs are stretchy, like balloons. When you inflate a balloon, it stretches to hold in the air. In the same way, as lungs inflate, the elastic fibers allow them to stretch. Now, if you release the air out of the balloon, what happens? Of course, the air is pushed out because the stretchiness of the balloon creates more pressure on the air inside it, and the sides of the balloon recoil. The lungs do the same thing. Their elasticity causes pressure on the air inside them, and thus they aid in expiration. There's a common disease in the lungs called emphysema that can be caused by smoking or irritation as a result of excess polluted air. What happens is the delicate walls of the microscopic alveoli break down due to constant irritation. Thus, many of the alveoli join together into a single large alveolus. Well, that results in a few problems. You see, the amount of surface area over which the blood is exposed to oxygen affects the rate at which that oxygen can make it into the blood. More surface area equals greater oxygen intake. Well, a large alveolus has less surface area than many small alveoli, so this results in less oxygen to be taken into the blood. Additionally, when the alveoli disintegrate, the lung loses some of its elastic tissue because the tissue is replaced with scar tissue. Thus, the lungs cannot work as well with ventilation, and people have a hard time exhaling. So if a person has emphysema, they don't have trouble taking in air, they have a hard time releasing it because their lungs have lost their elasticity and cannot recoil as well. So we know that elasticity is important for expiration, but there's another factor that helps. It's the surface tension of alveolar fluid. I haven't mentioned any fluid in conjunction with the alveoli, so let me explain. The lining of an alveolus is made up of simple squamous epithelium. It's delicate tissue, as I've mentioned before. That's why continual exposure to irritants can cause emphysema due to its breakdown. This membrane is a moist membrane, and it lines the entire inside of the alveolar sac. Well, moisture means that fluid is involved, and this fluid is primarily made up of water. You likely know that water molecules have an attraction to each other because they have slight positive and negative charges on their ends. So water is more attracted to itself than to air molecules. At the surface of water, there is something called surface tension. Surface tension is what allows an insect called a water strider to walk on the water's surface. That's because the water molecules are attracted to each other with a strength that is greater than the mass of the insect standing on it. You can see the dimples on the water's surface right here. Well, when an alveolus is inflated with air, the watery alveolar fluid stretches out along with the sac. That forces the water molecules to be pulled further apart from one another. But they don't want to be pulled apart. They have a natural attraction to each other, causing them to want to stay together. So when air inflates the alveolus with a strong enough pull, the alveolus will expand. But as soon as that force weakens, the resulting surface tension from the alveolar fluid will pull the alveolus back. That means that alveolar fluid helps with expiration, shrinking the alveoli and forcing air out of the lungs. To sum up then, elasticity of the lung tissue as well as alveolar fluid are two factors to aid in expiration. Now there are also two factors to aid in inspiration. They help to keep the lungs from totally shriveling up when you exhale. That makes them different than regular balloons, right? Well, the first process has to do with the anatomy of the lungs. The lungs are covered on the outside by a slippery, thin membrane called the visceral pleura, and there's another membrane covering the surfaces of the chest wall and diaphragm called the parietal pleura. These two membranes have a small space between them called the pleural cavity, and it's filled with watery fluid called the pleural fluid. Well, the two pleura are tightly attached to the lungs and chest wall and diaphragm. There's no air between them, just pleural fluid, and the pressure there is lower than the atmospheric pressure outside the body. That has to do with the elasticity of the lungs and the surface tension of the alveolar fluid. Those two factors cause the lungs to pull away from the chest wall, and the ribs pull the lungs outward because of their stiffness. So each pleural cavity is sealed, and the pull in opposite directions causes a vacuum or negative pleural pressure. Thus, the pressure in each pleural cavity is lower than atmospheric pressure. It's kind of like when you use a plastic food storage container and seal the lid, compressing it a bit as you close it. The flexible sides want to pull outward in order to straighten it out. That creates a negative pressure inside the container. When you open the lid, you can hear air flowing into it because the air pressure outside the container is greater than the air pressure inside it. Well, since the pleural cavity is lower than atmospheric pressure, there's some suction or pulling on the lung tissue holding it open. Therefore, even though the two factors that help expiration occur, the negative pressure of the pleural cavity balances it out so the lungs don't completely collapse due to those expiration helps. If the pleural cavity were to lose its vacuum, then air could move into that area, so the pressure in the pleural cavity would be the same as atmospheric pressure. But then there isn't any negative pressure to hold the lung open, and the lung would collapse. That condition is called a pneumothorax. Pneumothorax is air in the pleural cavity, which leads to a collapsed lung. Now, each lung has a separate pleural cavity, so if the seal on one lung is broken, then that side will collapse, but the other lung won't be affected. Thankfully, one working lung provides enough gas exchange to keep a person alive until the other lung can heal on its own or if the person needs medical help to reinflate it. The second process to aid in inspiration works opposite to the surface tension of the alveolar fluid. I already mentioned how fluid surface tension helps the alveoli to collapse back to their original shape, and that force is a pretty strong force. In fact, it's too strong, so it needs to be reduced. Well, it's reduced by surfactant, which is a molecule secreted by special lung cells that has a hydrophilic or water-soluble end and a hydrophobic or oil-soluble end. A surfactant is a detergent. Yes, it behaves like soap does. You see, detergents are made of very long molecules, with one end being hydrophobic and the other end being hydrophilic. So that means one end easily dissolves in non-polar material, while the other end easily dissolves in water. That's why soap cleans your body. The hydrophobic end dissolves in the oils of your body, and the hydrophilic end dissolves in the water you're using, and it's washed away with the water you use to rinse. Well, cells in the lungs make surfactant. The hydrophilic end moves toward the alveolar fluid, and the hydrophobic end forces any surrounding molecules away. As a result, water molecules are isolated from each other, and thus their mutual attraction decreases a bit. So this reduces the surface tension. In fact, if you were to add a drop of liquid detergent to the pond near where a water strider was resting, it would cause the water's surface tension to weaken, and that insect would need to move away quickly or it would sink. Well, when the cells of the lung secrete surfactant, that reduces the surface tension in the alveolar fluid, making the alveoli easier to inflate. Thus, surfactant aids in inspiration. Up until a few decades ago, a condition called infant respiratory distress syndrome used to be common in premature babies. The baby had a hard time breathing because, being born early, the lungs were not completely developed, and the cells were unable to make surfactant for the alveolar fluid. So the surface tension in the alveoli would be too strong, which makes it harder to inhale. Thankfully, prematurely born babies are treated with surfactant that is added to their lungs via the trachea until the baby has had time to mature and the lung cells can secrete their own surfactant. Let's talk further about babies and how they breathe shortly after birth. You see, before a baby is born, he or she gets oxygen and nutrients from the mother. But as soon as the umbilical cord is cut, then the baby has to breathe on its own. That first breath is the most difficult breath a person will ever take. It's because the compliance of the lungs is low. Compliance is the ease with which the lungs inflate. Let's go back to the balloon analogy to better understand this. You see, when you get a brand new balloon that's never been inflated, the elastic of the balloon is stiff, so it's very hard to fill it for the first time. But if you fill it, then release the air, and do that a few more times, then the balloon becomes easier to inflate, or its compliance increases. Well, the first breath is the hardest because the lungs have never been inflated. It takes a couple of hours of breathing before a baby's lungs have had the compliance that adult lungs have. One final point I need to mention. There's something called airway resistance. As air travels through the tubes of the lungs, the walls of those tubes resist airflow. That's airway resistance. The lower the resistance, the easier it is for air to flow through. The places of greatest airway resistance are in the bronchioles because of their tiny diameter. A disease called asthma is due to increased airway resistance. The bronchi and bronchioles have decreased diameters, increasing airway resistance and making it more difficult for air to make it to the alveoli. To reduce that resistance, sometimes people with asthma have to take medications to dilate or increase the diameters of the bronchi.